Okay, so yesterday and the day before we started our vector section. So this one starts with the component form and the magnitude. Remember, if you've got the component, or if you're asking for the component form and you've got your initial and your terminal, this would be my x1, this would be my y1, this is my x2, this is my y2. And I want to do the change in x and then comma the change in y. So it would be -8 minus 1, comma, -9 minus 3, and I get -9, -12. So that's the component form of this. And it's important that it's in that order, and important that they're both negative. If you switch the signs, obviously you're doing like the initial minus the terminal. You don't want to do that. Then for B, the magnitude, you have two choices. You can either do the distance formula from the beginning, or because we already have the component form, it's easier just to square the A, square the B, and then put their sum underneath the square root. So square root of A squared plus B squared would be 81 plus 144. That's 225, and the square root of 225 is what? 15. Okay, so that can be simplified. Good. Then we got into adding, subtracting, scalar, all that good stuff. So number 2 says use U as -5, 3, and V as 2, -1 to find. Number 2 says 2U plus V. So you can take that 2 and distribute it in on the U, and then add to it the 2, -1. So distribute here, and I get -10, 6, and then add that to the 2, -1, and I get -8 and 5. Because it gave it to me in component form like this, I want my answer to be in component form. If it gave it to me in IJ, I would put it back in IJ. Then number 3 says 5U minus 3V. So 5 times U minus 3 times V. Distribute, I get -25, 15. Distribute, so I'm going to keep the negative here, distribute a +3. You could also distribute a -3, but change the sign in between to plus, and it's okay, it's the same thing. So 25 minus 6 is -31, and then 15 minus a -3 would become 15 plus 3, which is 18. And again, because it's given to you in component form, we want it back in component form. Questions on any of those? So those would have been like from day 1. Okay, then we got to IJ format. So number 4 says if U is -3I plus 4J and V is 2I minus J, find 2U minus V. So yesterday I said it, but I'll say it again. You have the option to put that into vector form and then put it back into IJ at the end. Or I think it's easier, just treat them as though they're variables. So I would get 2 times U minus V, and then distribute, and then combine your like terms. So distribute here, and I get -6I plus 8J. Distribute the negative to both, so minus 2I plus J, and I get -8I plus 9J. So we had just had the conversation that on WebAssign it required you to put that like special I and special J on that. And sorry, I forgot to say that to you. But also test-wise, you won't have to. Like test, you'll just use your regular IJ. So if this was a question on the test, it has to be in IJ format or it will mark it wrong. Like if you put -8, 9, it will mark it wrong. You need to make sure it's in IJ format, and you'll just use your regular variables, your regular letters. No spaces. So there would be no spaces on that statement. And the order matters. I comes first. All right, number 5 says find a vector in the same direction as number 1 with a magnitude of 3. So my vector from number 1 is -9, -12. Right? Yep. -9, -12. And then I want to put that in the same direction, which means put the component form over the magnitude. So we already found the magnitude was 15. I just have to split this, so it would be -9 over 15 and -12 over 15. They're both divisible by 3, so I can do -3 over 5 and -4 over 5. If it had said to put it in IJ format, it would be -3/5 I minus 4/5 J, like that.
I have a question.
Wait, where did you get
get the 15 from?
It was in question 1. So if you go back to question 1, we found the component form and the magnitude of that. Oh, sorry, wait, I'm not finished though. That would be if it's in the same direction and has a magnitude of 1, right? That would be a unit vector, so I shouldn't have highlighted it. So if it had said unit vector, I would be done. Like if this wasn't here and it said unit vector, that would be my answer. But this time it says I don't want it to be a unit vector, I want it to have a magnitude of 3. So what I take is at the end of this, I just take 3 and multiply it in. So I'd get negative 9/5 and negative 12/5. So a unit vector, I do the component form over the magnitude, but this time it says with a magnitude of, which means it's not going to be a unit vector because the unit vector has a magnitude of 1. You just find the unit vector and then at the end multiply the 3 in or whatever you want the magnitude to be. Does that answer your question? Yeah, okay. All right, number 6 says 2u plus v. So I've got my graph here. Remember for u, if it's 2u, I want to double the length. So if this is my typical u, I want to double it in the same direction about there. That would be 2u. And then if I want to add it, I draw out my little parallel lines. And then where they intersect is the terminal point of their resultant vector. You will have to graph on your test. It will go on your answer sheet. I will look for that on your answer sheet, so just keep that in mind. And we'll graph one more thing when we get to 6-5. Questions on any of that warm-up? Okay, so these were the questions from the homework that were asked. This is number 8. It said find the vector v with the given magnitude in the same direction as u. So I want to find, like we just did, I want to find the vector format or the unit vector of 6i minus 7j. And then I want to multiply in the 14 at the end. So if I was to put that in component form, it would be 6 negative 7. And then it would need to go over the square root of 6 squared plus negative 7 squared. 36 plus 49, which is 85. So I end up with 6 over the square root of 85, negative 7 over the square root of 85. I'd rationalize it, so it'd be 6 root 85 over 85, negative 7 root 85 over 85. If it had asked for a unit vector, I'd put it back in IJ, but then I'd be done. The fact that it says the magnitude is 14 means at the end I have to take that 14 and multiply it in on my vector. So that's where the 84 root 85, over 85 minus, it would be 7 times 14, so 98 root 85 over 85. That would be the component form. This was asking for it in IJ format because the original is given to you in IJ format. So it would be 84 root 85 over 85i minus 98 root 85 over 85j. And that's how the answer should have been formatted. So I said it yesterday, WebAssign let you keep that square root in the denominator. When you go to take your test on this, I'm looking for the rationalized answer. Yep.
Can I just see the answer for number 5?
When I'm done with this one, I'll go back. Questions on that? All right, number 10 said find the component form of v and then sketch the specified vector operation geometrically, which just means draw it on a graph, okay? U is 4i minus j and w is i plus 4j. So if it wants you to find v to be u minus 4w, I'd get u, which is 4i minus j, minus 4 times w, which is I, plus 4j. 4i minus j, distribute this, negative 4i minus 16j. Combine your like terms. These actually cancel out. And then I get negative I, negative 16, or negative 1j, negative 16j, which is negative 17j. So this, in component form, it's just why it says that, would be 0, negative 17. And then to draw it out, like if I went off of that, it's literally just 0 all the way down to negative 17. And that's my resultant. The graphs gave you the sum of them, like they gave you both. So if I drew first 4, negative 1, it'd be to the 4, negative 1. It'd look like that. And 1, 4 would look like this. And then you did u minus 4w. The u would stay exactly how it is, and that's the green. But the w has to switch direction 1, 2, 3, 4, and go 4 times its length. And then you want to extend your parallelogram out. So it's a little bit off because this is not exactly 17. But it should have been like that. So again, keep in mind you will be graphing these without the actual coordinates. So make sure you know how to double the length. You make sure you know how to make it negative. Make sure you know how to add the two together. Okay, so just the last example in 6.3, because it's good review of a couple of things, says two forces, F1 and F2, of magnitude 5 pounds and 12 pounds, respectively, act on an object. The direction of F1 is north 20 degrees east, and the direction of F2 is north 75 degrees east. Find the magnitude and direction of the resultant force. Express the magnitude to the nearest hundredth of a pound and the directional angle to the nearest tenth of a degree. So we've got two things going on here. One, obviously, we're dealing with the vectors, but two, we're going back to the bearings, right? Remember, we did bearings in sections 1 and 2. They will come back on your test, so you want to make sure you understand them. So I have two forces which just act like they're vectors, okay? They're just a line. So if I drew out a coordinate grid, cross my lines, my north-south, my east-west lines, and I wanted to map out north 20 degrees east. Which direction am I going? Up and right. So I'd go up north, and then I'd go out east, and that would be 20 degrees. And there's a vector there. That vector, so that's F1, that vector has a magnitude of 5 pounds, which is the force. So that is 5. Magnitude there is 5. Then I've got F2 going north 75 degrees east. Which direction is that? Up and right again. North, so still going up. This time I'm going out 75 degrees though, so a little bit further. And there's that vector. So the 75 is the degrees on that. And the force there is 12 pounds. So the way we measure these vectors is, I don't know if you remember from yesterday, but we take the magnitude and we times it by the cosine and the sine of the angle it makes with the x-axis. Are those the angles that I was given? Is 20 the angle it makes with the x-axis? No. It's the angle it makes with which axis? The y-axis. So now we've got to subtract it. So I'm going to do 90 minus that 20. And this actual angle would be 70 degrees. And I'm going to do 90 minus 75. And this angle is actually 15 degrees. Does that make sense? So the bearing is always from the north-south line out, which is your y-axis. When I'm trying to find the component form and I have magnitude and angle, it's the angle it makes with the x-axis. So in order to find the component form of that pink, that F1, I would do the magnitude, which is 5, times the cosine of 70 degrees. And then the magnitude again, that's 5, times the sine of 70 degrees. And this is 1.71 and 4.69, or so it's 70. That's the component form of F1, which is the pink one. Then I have to do the component form of F2. This time my magnitude is 12 times the cosine of 15 degrees, and then 12 times the sine of 15 degrees. So I get 11.59 and 3.11. That's the component form of the individual vectors. With me so far? Then it said find the component, or find the magnitude and the angle from the resultant force. Resultant means sum. Add these two together. What would happen if two forces were acting on the same thing? I would take the component form of one and add it to the component form of the other. Okay? So I'm going to do 1.71 plus 11.59 and 4.70 plus 3.11. 1.71 plus 11.59, 13.3, 4.7 plus 3.11, 7.81. That's the component form of the resultant. So this is F1 plus F2. I need the magnitude of the result. So I'm going to do the square root of 13.3 squared plus 7.81 squared. So this is now the magnitude of the sum. Square root 13.3 squared plus 7.81 squared. And that's 15.42. So that's the magnitude of the resultant, and now we need the angle. We did it yesterday. How do I find the angle?
It's like tan inverse.
Good. So the tan of theta would equal the change in y over the change in x of F1 plus F2, which means come back here and do the tan -1 of 7.81 over 13.3. And I get theta equals 30.42 degrees. So if I had actually extended this, if I had like measured that to be exactly 70 degrees and it acts exactly 15 degrees, and I measured those both out, and I plotted this point, and I drew it out, and the 5 was actually 5, and the 12 was actually 12. If I measured that angle formed now by that black vector, it should be 30 degrees, and if I actually measured it in unit form, it should be that 15.42. So length and direction. Like I said, I think this is like that. I didn't put this on your test. I do want you to know it. You do need to understand the horizontal component and the vertical component, like the word problem we did yesterday, but I didn't put this on your test. I just want you to know that there's the application, obviously, of what we're doing in vector form for things like physics and force and that kind of stuff. What is on your test is include 6.4. So 6.4 is called vectors and dot products. So we're continuing with vectors in this section. 6.5 is different, but 6.4 is continuing in vectors. But we're going to learn something called the dot product. And then we're going to use it a whole bunch of ways. So the dot product is how we multiply vectors. When you multiply vectors, you don't actually just multiply the numbers and keep them in their x, y's like you do with adding and subtracting. You multiply the first times the first. You multiply the second times the second, but then you add them together. So the dot product is a single number, just one number. I would take this, multiply it times this, take this, multiply it times this, and then add them together at the end. Example 1, find the dot product of u and v. So we're in both formats, right? One's a component form and one's ij. So for the first one, I literally take the first times the first, so 6 times -2, and I add it to the second times the second, 1 times 3. And I get -12 plus 3, which is -9. Easy stuff, right? You just got to remember to add them together at the end because people mess that up. B, you can rewrite this in component form if you need it. 3, 4, -2, -3, and then first times first plus second times second. Or multiply these two together, multiply these two together, and then add them at the end. You don't have to put it in component form.
So you don't have to put like an I or a J?
Nope. It's just a single number. Good so far? Yes? Okay, so these are the properties of the dot product. These are all the things we can do with them. Okay? The order can be moved around. So these are commutative, just like multiplication is. I could switch u times v and v times u, and it would be the same thing. I can use the distributive property on this. So I have u dot a sum. I can actually add the two together first and then multiply it. Or I could take what's on the outside and distribute it in and then add them at the end. The dot product of any vector and itself is the same as squaring its magnitude. So if I have two of the same vector, they have to be the same vector, okay? If I'm doing u dot u, it's the same thing as finding the magnitude and squaring it, which means like get rid of the square root.
So if he squared an equation, you could change it to the magnitude squared.
It doesn't matter. You could do either one. So if you saw, we like substitute it in, you mean?
Yeah.
This is more like it would say u is 3, -2, v is whatever it is. And then the question will actually say find u dot u. So I could literally take the dot product. I could do this times itself. 3 times 3, which is 9, plus -2 times -2, which is 4, and add it together. Or I could find the magnitude of that vector and then square it. Means gets rid of the square root. Just do a squared plus b squared. It's the exact same thing. So you can choose how you do that. Yep.
Where does the W come from?
W is just a third vector. So you'll see vectors like W, V, U. They're usually lowercase bolded letters at the end of, I don't know why they pick those, but they do. And then C is a scalar in this case, so it could have been K, it could have been whatever it is, but let's say C is the scalar. When you're doing the scalar times a dot product, so if it had said 2u dot v, again, think about this in terms of multiplication. That's kind of all the same weight as multiplication. I can either do u dot v first, which is what usually we do just because our brain says parentheses, do that first, and then multiply that product by 2. Or I can do 2 times u, find that product, and then take that and do the dot product with v. Or I can do 2 times v, and then take that result and do it times u. You do not want to distribute with a dot product inside the parentheses. That's what you don't want to do, okay? If that was plus, you distribute. If it's a dot, you don't distribute. Just think about it. If it said 2 times x times y, what would the answer be there? 2xy, not 2x times 2y, right? We don't distribute when it's multiplication. So the rules of multiplication pretty much apply to dot product. It's just at the end you add them together. All right, so this one says use u as -5, 6, v as -3, 4, w as 1, -2 to find the indicated quantity. State whether the result's a vector or a scalar. So start with A. It says u dot u. So remember we have two choices. We literally can just take u and use the dot product with itself. Or we do a squared plus b squared because it'd be the same thing. So -5 times -5 plus 6 times 6, 25 plus 36, which is 61. Now, is that a vector or a scalar, and how do I know the difference? What's a vector look like? What does it look like in number form?
Oh, two.
Two numbers separated by a comma. Yeah? What's a scalar look like?
Was it?
A single number. So this is a scalar. So if it's a single number, it's a scalar. If it's two numbers separated by a comma or an ij, it's a vector. All right, now look at B. What would you do first?
Distribute inside to the top.
Say that again.
Inside the parentheses first.
Do the inside the parentheses first. Okay, so then inside the parentheses, what would you do first?
You would multiply together V and W.
Okay, so you could do V times W first and then multiply it by 3. Yeah. What else could you do?
Multiply W by 3 first.
I could do 3 times W first and then take that and multiply it times U. Yes? Does that make sense?
Times V or times U?
Times V, sorry, times V. And then that times U. Yeah. So you can do any of those because it's all multiplication. It has equal weight. So parentheses don't change the order we do multiplication, right? So I could do, what did we say first? You said W times V. So let's do 3 times W times V, and then just don't forget to come back and multiply it times U. So W times V would be, 3 is still on the front, negative 3 times 1 plus 4 times negative 2 times U at the end. 3 times, this is negative 3 plus negative 8, so that's negative 11 times U. And again, I can do that in any order I want. So let's do 3 times negative 11, that's negative 33 times U. U is negative 5, 6. So what do I do with that negative 33? Good. Distribute it in. So this would be 165 and negative 198. Is that a scalar or a vector? Vector. Questions on those? All right, now we're going to do some application on dot product. One way is to use the dot product to find the magnitude, okay? So because we said the dot product of any vector n itself would be the same thing as squaring the magnitude, we can work in a reverse and say if I square root the dot product, I should get the magnitude. So now I have another option. If it gives me a vector and it says find the magnitude of this vector, I could do square root of a squared plus b squared, or I could do square root of the dot product. It's the same thing. So we have an extra, remember we could do square root of a squared plus b squared. That's the original way to find the magnitude. So now I have another option. And I don't care how you do it. I would practice it for now, the dot product one. But if you got a quiz and it just said to find the magnitude, or on your test it said magnitude, I don't care which method you use. So it says use the dot product to find the magnitude. So we just said it would be the square root of u dot u. So for A, I'm going to do u dot u. So I'm going to duplicate u, because for me, I like the visual. You could do it the other way if you want. I'm going to do 3 times 3 plus negative 4 times negative 4, 9 plus 16, which is 25, and then I square root it, and my magnitude is 5. I would get the same answer by doing the square root of a squared plus b squared. It's just another way to do it. All right, what about B? What is 3i in component form?
Just
3, 0. So I would do the square root of 3 times 3 plus 0 times 0. I get the square root of 9, which is 3. Questions on that one? I hear you.
Just so much fun.
Right? Okay, the angle between two vectors, and these should be double lined on the bottom. Oops. Double the lines. Okay, the way we find the angle between two vectors is that the cosine of that angle would be the dot product over the product of the magnitudes. So at the end, I'm going to cosine negative 1. Cosine negative 1, the dot product. So I take those two vectors, I find their dot product. The magnitude of the first times the magnitude of the second. So when I'm given two vectors, I have to find their dot product and I have to find their magnitude. And then I would inverse cosine. The dot product is going to be a single number at the top divided by the magnitude. So in the bottom, it can be square roots, it can be whole numbers, but you just let the calculator do the work. All right, so A says, the directions say find the angle between the given vectors. A is 1, 0, and V is 3, negative 2. So I'm going to do U dot V over the magnitude of U times the magnitude of V, and I'm going to cosine negative 1, that whole thing. So the dot product would be 1 times 3, which is 3, plus 0 times negative 2, which is 0. Dot product is 3. Then I need the magnitude of U, which is the square root of 1 squared plus 0 squared, square root of 1, which is 1. And I need the magnitude of V, square root of 3 squared plus negative 2 squared, 9 plus 4, square root 13. So then the cosine of theta equals the dot product, which is 3, divided by the magnitude of U, which is just 1, and then the magnitude of V, which is the square root of 13. Yep. Nope, because you're going to let the calculator do that step. So cosine negative 1 is 3 divided by the square root of 13. And then you let your calculator do that for you. We're going to keep two decimal places, 69 degrees. And if I had a coordinate grid, or you want to like draw this loosely by hand, if I had drawn out 1, 0 would be to the right 1, it would look like this. That would be vector U. And then 3, negative 2, 1, 2, 3, negative 2 would be there. The angle between here is what I'm trying to find. So you won't be 100% accurate, like you're not going to be able to take out a protractor and measure it, obviously, but you should at least be on the right track. Does that look like it's less than 45? Yes, if I drew it out, it's definitely less than half of it. Okay, is it closer to 90 degrees? Is it obtuse? That kind of stuff you should be able to find. All right, we're going to pick up with B tomorrow. Let me tell you what number you can get to on the homework so that you don't overwhelm yourself over the weekend.
You want to present
All right, you can get 1 through 7. It's only 3 questions after that. You can complete 1 through 7 where we're at now. My advice is do it tonight so you don't get stuck with all of it over the weekend. 1 through 7. Have a fantastic day, guys. Bye.